Hey everyone, and welcome to the Deep Dive. Today we're diving into the world of quantum computing.
A world that's quickly becoming less sci-fi and more, well, reality.
And to guide us on this deep dive, we've got a really interesting episode of the Impact Quantum podcast,
It's a great podcast for anyone who is, quantum curious.
which we're assuming is most of you listening right now.
So let's break down exactly what quantum computing is
And more importantly, why it matters.
and how it might just change everything.
From like the environment to, our everyday lives.
Pretty big claims, huh?
Yeah, pretty big. So, okay, classical computers,
The ones we're all familiar with.
they use bits, which are either a 0 or a 1,
But quantum computers use qubits.
and they're different.
Yeah, they operate by a whole different set of rules.
So what makes these qubits so special?
Well, imagine a coin spinning in the air.
Okay, got it.
It's not heads or tails until it lands, right?
Right.
That's kind of like a qubit. It can be in this state called superposition,
Superposition.
where it's both 0 and 1 at the same time.
Whoa.
So it can, explore tons of possibilities all at once.
Okay, so it's not just like faster, it's like fundamentally different in how it solves problems.
Exactly. It's this quantum weirdness.
Quantum weirdness, love it.
And it lets these quantum computers do things classical computers just can't.
Hmm.
Like Shor's algorithm,
So Shor's algorithm.
which is designed specifically for quantum computers.
Okay.
It can factor large numbers way faster than any algorithm for classical computers.
Now the Impact Quantum episode talks about like how this could be a threat to how we do encryption today.
Yeah, that's right. Think about it. Our online security,
Yeah.
financial transactions,
Hmm.
pretty much everything relies on how hard it is for computers to factor large numbers.
Right.
But Shor's algorithm
On a powerful enough quantum computer?
could crack those codes.
Oh.
Yeah, putting all sorts of sensitive data at risk.
That sounds kind of scary.
It is a little bit like a ticking time bomb.
It is, yeah.
We really need to come up with some quantum-resistant encryption methods.
Like yesterday.
Yeah,
Okay, so on the one hand, we've got this potential security threat.
right.
But on the other hand, the episode talks about all this amazing potential,
Mm-hmm.
especially for the environment.
Especially for the environment, yeah.
Can you tell me a bit more about that?
Well, one of the most exciting areas is how we produce fertilizer.
Okay, fertilizer.
So right now, we use this thing called the Haber-Bosch process.
Haber-Bosch process.
It creates nitrogen fertilizer, but it uses a ton of energy.
Like how much?
About 1 to 2% of the global energy supply.
Seriously. I had no idea it was that much.
It is, and that means it also contributes a lot to greenhouse gases.
Oh, wow.
But quantum computers
Yeah.
could help us simulate and copy how nature fixes nitrogen.
Which is
Much more efficient,
Oh.
eco-friendly.
We're home like quantum computers helping us create green fertilizer.
Exactly.
Well-
Imagine what that would mean for global energy and the environment.
Totally.
It's a great example of how this tech could help us build a more sustainable future.
Absolutely. Okay, let's shift gears a bit and talk about material science.
Another area with huge potential.
The episode mentions this, but I'd love to learn more.
Sure. So think about solar panels.
Okay, solar panels.
Great for renewable energy, right?
Mm-hmm.
But they're not that efficient.
Right.
Quantum simulations, though, could help us design new materials.
What kind of materials?
Ones that can absorb sunlight way more efficiently. Much more efficient solar panels.
Wow. So we could see a huge jump in solar energy production.
You got it. And it's not just solar panels.
Uh-huh.
We could make lighter and stronger materials for, aircraft.
Wow.
Or better batteries for electric cars.
The possibilities, I mean.
They're huge.
They are. It's amazing to think that we might be on the edge of this materials revolution.
All thanks to quantum computing.
It's incredible.
And it goes beyond just, engineering and materials.
Oh.
The episode also talks about how quantum computing is being used in finance already.
Oh, yeah. I can see how being able to do those complex calculations super fast would be a game changer there.
Oh, yeah, for sure. Financial institutions are already using it. Things like simulating market trends, managing risk,
Okay.
and optimizing investment strategies.
It seems like quantum computing is impacting way more fields than I even realized.
It's not just some far-off concept anymore. It's here.
Totally.
And the pace of all of this innovation is just speeding up.
Yeah.
So widespread personal quantum computers might still be a while off.
Okay.
But cloud-based access, That's becoming more and more available.
And so instead of having a quantum computer on my desk,
Right.
I might access it through the cloud.
Exactly.
Interesting.
It's like how we use cloud computing today.
Makes sense.
It's making this technology way more accessible.
So driving even more new applications.
Exactly. It's still early days,
Yeah.
But the future of all this,
Yeah.
incredibly exciting.
Totally agree. Okay, so we've covered a lot.
We have.
From the basics of qubits to, like, the potential for quantum computing to change everything.
Cybersecurity, fertilizer,
Yeah.
you name it.
But there's so much more to explore.
Oh, yeah.
And in the next part of our deep dive, we'll be looking into this mind-boggling idea of quantum entanglement
Oh, it's going to get even more interesting, trust me.
and its implications for communication and even teleportation.
Stay tuned.
Welcome back to the deep dive. Before the break, we were talking about how quantum computing could revolutionize things like materials, science, and finance.
Yeah, some pretty big stuff.
But now we're going even deeper into the quantum realm
That's right.
to explore one of its most mind-bending aspects,
Okay, and what's that?
entanglement.
Ah, entanglement. Now, this is where things get really, really weird.
Okay, lay it on me.
So, entanglement is like, imagine two particles,
Okay.
but they're linked
Linked how?
in a way where they share the same fate.
Same fate.
Yeah, no matter how far apart they are.
So, like, if you measure one,
You instantly know the state of the other one,
even if they're, like, miles apart.
even if they're light years apart.
No way.
It's crazy, right?
It really is. So it's not just that they're connected. It's like they're two parts of the same, I don't know, like the same whole or something.
Exactly. It's like they're acting in unison.
And this is what Einstein called, like, spooky action at a distance.
Yeah, he wasn't a big fan of it.
I can see why. So what are the implications of this spooky action?
Well, the Impact Quantum episode mentions unbreakable communication.
Unbreakable communication.
Yeah.
Okay, how would that even work?
Imagine a system where your messages are like encoded in the entangled states of these particles. And if anyone tries to intercept the message or eavesdrop,
Yeah.
it disrupts the entanglement,
Oh.
alerting both the sender and the receiver.
So it's not just about encrypting the message. It's like making the act of interception itself detectable.
Precisely, like a built-in alarm system.
So this could be huge for, like, government communications.
Absolutely. Military operations, financial transactions, protecting personal data.
Wow. Okay, so this entanglement thing, it's not just some theoretical thing.
No, not at all.
The episode also mentions teleportation,
Ah, yes, teleportation.
which, I mean, come on, it sounds like Star Trek.
It does, doesn't it?
Yeah.
But quantum teleportation is a real thing.
Really?
Yeah, they've even done experiments with it.
With-
photons
Okay.
and even atoms.
So are we talking, like, beaming people across the galaxy?
Not quite yet, but what we're teleporting isn't the actual matter.
Oh.
It's the quantum information.
Quantum information.
Yeah, the information that defines its state.
So instead of moving the object itself, we're transmitting, like, the blueprint.
Yeah, exactly. It's like sending instructions on how to recreate it somewhere else.
Yeah, that is mind-blowing. But how is this useful?
Well, it could be huge for building powerful quantum computers and networks.
Oh, okay, I see. How so?
Imagine a quantum internet, where information is transmitted instantly, securely, through entanglement.
Wow.
Instead of connecting qubits with wires, we could use teleportation.
To create these vast networks.
Exactly.
And what could we do with that?
Global timekeeping, that's super precise.
Uh-huh.
Distributed quantum sensing,
Okay.
even more powerful quantum computation. The possibilities are huge.
That's incredible. But the episode also says that, building these quantum computers is really hard.
Oh, yeah, it's not easy.
What are some of the big challenges?
Well, one of the biggest is something called decoherence.
G-coherence.
Remember we talked about how qubits can be in this superposition of states?
Yeah, both 0 and 1 at the same time.
Right. Decoherence is like when they lose that superposition,
How it happens.
they collapse into a definite 0 or 1.
Oh.
It's like a delicate bubble that bursts.
Because of...
Noise, disturbances from the environment, all sorts of things.
So it's like super fragile.
It is. And this decoherence, it introduces errors into the calculations.
Oh, I see. So how do you prevent that?
Well, you have to create extremely isolated environments for these qubits.
Like a quantum sanctuary.
Kind of. You have to shield them from any outside interference.
And this involves...
Cooling them down to super low temperatures.
Like how low?
Just a fraction of a degree above absolute 0.
Wow. So we're talking like seriously advanced engineering here.
We are. But even then, decoherence is still a problem.
So what else could you do?
Well, researchers are working on these things called error correction techniques.
Error correction.
Yeah, quantum algorithms designed to, like, detect and correct the errors.
In real time.
Yeah, like a team of microscopic repair crews.
That's wild.
And it's not just isolating individual qubits.
Right, because you need lots of them.
You need hundreds, thousands of them to do really complex calculations.
And that's hard.
Really hard. It's a huge engineering challenge to connect and control them all while keeping this decoherence thing at bay.
I can imagine.
And then there's the software side of things.
Oh, right, because you need to be able to program these things.
Exactly. We need new quantum algorithms.
Okay.
And software that can take advantage of what these computers can do.
So we've got the hardware challenges and the software challenges.
It's a lot.
It is. Okay, so we've explored entanglement,
Spooky action at a distance.
decoherence,
Fragile qubits.
and the potential for these quantum computers to change so much.
Communication, materials design, it's huge.
But what about the bigger picture? The impact on society. Welcome back to the Deep Dive. We've been exploring this world of quantum computing.
It's a field that's, I don't know, just so fascinating.
It really is.
And like pushing the boundaries of what we thought was possible, you know?
Absolutely. And as we get closer to like realizing the full potential of quantum computing, we really need to think about the impact on society.
Oh yeah, for sure.
The Impact Quantum episode talks about this.
It does.
And I'm curious, like, what do you think a quantum-powered future would actually look like?
Well, I think it's a future with a ton of possibilities, but it's
Yeah.
also one that needs, like, some careful thought.
Right.
One area that could see a huge transformation is healthcare.
Healthcare.
Yeah. Imagine, like, personalized medicine tailored to your, unique genetic makeup.
Wow.
New drugs and therapies designed using these quantum simulations. We could even have, like, earlier and more accurate disease detection. Quantum sensors.
So it's like precision medicine, but like on a whole other level.
Exactly. It's understanding and treating diseases at a level of detail we can barely imagine right now.
And beyond healthcare.
Oh, there's so much more.
Yeah.
I think we could see quantum computers helping us solve some of the world's biggest problems. Climate change.
Oh, wow.
Yeah. Quantum simulations could help us develop new catalysts for capturing carbon, design, more efficient energy storage systems, even optimize like whole energy grids.
To make them more sustainable.
Exactly.
It's incredible to think that like this tech that comes from studying the subatomic world could have such a big impact on, the planet.
It really shows you how everything is connected.
It does, yeah. What about like artificial intelligence?
Oh, that's a big one. Quantum computers could completely change AI.
How so?
They could make those algorithms way faster.
Okay.
Help them process information and solve problems like way quicker than we can imagine now.
So we're talking breakthroughs in like machine learning.
Oh, yeah, for sure. Natural language processing, robotics.
Which would then transform like what? Transportation, logistics.
All of that. Scientific research, creative arts, the list goes on.
It's mind-boggling to think about all that potential.
It is.
But it also makes you wonder about the downsides.
There are always downsides.
Like the episode mentions job displacement.
Yeah, that's a big one.
As these machines get, more powerful, more common,
Right.
how do we make sure the benefits of quantum computing are shared, fairly?
That's the key question, isn't it? I think it comes down to being proactive.
Proactive how?
Governments, industries, educational institutions, all working together.
Okay.
We need to invest in retraining programs, help people learn new skills.
So they can adapt to the changing job market.
Exactly. The quantum revolution isn't just about technology, it's about society too.
And that means thinking carefully about the ethics of it all.
Absolutely.
And making sure everyone benefits.
Couldn't have said it better myself.
So as we enter this quantum era, it's up to all of us to make sure it benefits all of humanity.
A future that needs, I think, our curiosity, our ingenuity, but most importantly, our wisdom.
Well said. And on that note, I think we've reached the end of our deep dive into quantum computing.
It's been a fascinating journey.
It really has. Thanks for joining us, everyone.
And keep exploring. You never know. You might be the one to make the next big quantum discovery.
Until next time, keep those quantum questions coming.